So while there's a lot of different coordination numbers that can be found anywhere from kind of like 1 to I think like 15 or 16, some are simply more common than others. So the most common coordination numbers are 2, so attached to 2 things, 4 things. I'm going to write this twice, you'll see why in a minute, and then 6 things. So when we have these different attachments, we can have different geometries, right? Different geometries. And so if we think about 2 attachments, we have some kind of metal with 2 ligands in it. If you think back to Chem 101, you should be able to solve that this is going to be a linear geometry. So it's kind of like ML2. Here we have kind of like an ML4 situation. And so there's actually 2 different ways, or 2 most common ways this can be organized. The first, thinking back to Chem 101, should be pretty easy to figure out. And it's going to be into that traditional tetrahedral coordination. But then if you think about Chem 101, there was another one that had kind of 4 attached things to it. And that's if all 4 of these ligands are in the same plane. So remember, this was known as square planar. The main difference between this transition metal and some other main group element is that this transition metal does not have these kind of lone pairs above and below, but it still adopts this square planar geometry. And then finally, we have 6 ligands, so ML6. If you think back to Gen Chem 101, you'll know that 6 attachment points will get you to an octahedral shape. Remember, it's called octahedral because there's 8 faces, not because there's 6 things, right? Octa means 8 faces. And so here's just a picture of that. Again, note that the charge of the transition metal doesn't have much to do with what shape it adopts.